Howdy, this is BuilderDude35, and this week I'm going to be covering how to make a proportional wall follower for your EV3 robot. Now, some of you who have been with me for a while know that I already covered this topic back a few months ago, but I decided I want to go over it again and make a new video showing how you can apply proportional logic to your wall follower in order to make a more sophisticated wall follower. So, let's get to the programming. Alright, so the EV3 software is open, and let's build a wall follower. First, a quick explanation of proportional logic. I've gone over it a few times before, so I'll be really brief. We're first going to set a Goldilocks zone, the distance we want to be away from the wall, and we're going to have the ultrasonic sensor measure how far away from that Goldilocks zone it is. And if we're at the Goldilocks zone, we're not going to make any correction, and then the farther away we get from that Goldilocks zone, the greater of a correction the robot's going to make. So first things first, we're going to set our Goldilocks zone using a variable. We're going to go to this red section here, take out a variable. We want to write a numerical value, which is the default setting, and up here we're going to name our new variable. In my case, I'm just going to name it distance because that's the easiest thing to remember. We're setting the distance we want the robot to follow from the wall. And now we're going to set the value, the number of units we want the robot to be away from the wall. In my case, I'm just going to use 5. This can be any distance you want, and we haven't decided whether or not we're using inches or centimeters yet. That's going to come later. The second thing we're going to drag out is a loop block, which is going to come right after this. Right now it's set to unlimited, which is, I hope, what you don't want it to be at. You can set this to exit the loop with whatever case you want. That's going to be specific to whatever you're doing. I'm just going to set it to unlimited now for the purpose of example. Moving on, what we're going to do is take a sensor block, an ultrasonic sensor, and I got a lot of questions on the last video about whether or not this works with the infrared sensor. Yes, it does. It works the exact same way with an infrared sensor. You just replace this block with infrared. So we have it on measured distance centimeters, which is exactly what I would like it to be on, and of course you can change it to inches if you'd like, but we want it to measure distance. The next thing we're going to do is take out another variable block and put that right after here. We want it with our previous variable distance. By default it already matches the variable that we had before, so that's great. And instead of writing, we're now going to read. And the purpose of using a variable is so we don't have to keep writing the same number over and over again, and we can just change it in one spot. Moving on, we're going to take a math block. We're going to set it to subtract, just like that. And in the A case, we're going to take the result of our ultrasonic sensor, and the B case is going to be our distance value, which is 5 in my case, and the result is going to go into another math block. Now, so far we've done generic things that will work for everybody. Now you need to decide which side of the wall you're going to be following on. Are you going to be on the left side, or are you going to be on the right side? Now, if you're following on the right side of the wall, you don't need to make this next change, but I'm going to be following on the left side of the wall, so I'm going to take an extra math block. I'm going to change this to multiply, and we're going to set b as -1, and we're going to take the result of the previous math block and plug it in as a, and this is just going to multiply all of the result by -1, because if you're on the left side of the wall, you need to steer in the opposite direction than if you were on the right side of the wall. The next thing to do is take out yet another math block. Yeah, we're doing a lot of math today. We're going to change this to multiply. You're going to take the result of whichever math block comes previously and plug that in as the A, and this B value is going to be arbitrary, whatever you feel like it needs to be. Of course, we need to scale the correction made by this program, because if you think about it, if you're 2 centimeters off from your Goldilocks zone, it's only going to make a correction of like 2%, and that's almost nothing. That's not enough to really do anything with your robot. So I'm just going to put 10 right here. You can change this value to whatever you want, and I encourage you to fiddle around with this value and see which works best for your robot. the higher this value is, the greater of a correction it's going to make. And the lower, of course, it's going to make smoother corrections. And then finally we get to the last block in the program, which is a move steering block, and that's going to go at the end. We have BC selected as our motors, and those should be our drive motors. We're going to change this to just on. This power level is arbitrary again. The slower you have it, the more accurate it's going to be, but like I said, you could just have it whatever power you'd like. And we're going to take the result of this and plug it in as the steering value for this. And I do realize that this -1 and this 10 can be condensed into one math block, but I'm leaving them separate just because this is optional for just being on the left side of the wall. Now what we have here in our program is we're setting our Goldilocks zone, which is 5 centimeters. That's how far away we want to be from the wall. Then we're taking the ultrasonic sensor's value and subtracting 5. So if the ultrasonic sensor's value equals 5, then our result is going to be 0, and we're not going to make any correction because we're already where we want to be. If it's greater than 5, it's going to come out as a correction that's going to move us closer to the wall, and if it's less than 5, then we're going to move farther from the wall. And that's pretty much how this works. And of course, the farther away that you are from your 5 centimeter goal, the sharper of a correction it's going to make. So let's take this program, download it onto the robot, and see how it works. Thanks for watching my tutorial this week. If you found it helpful, be sure to subscribe for more tutorials like this every week. And if you have an idea for a tutorial, be sure to submit it in the comments section below. Thank you, and I'll see you next time. Bye.